our next speakers, as I said, they're going to talk about taming chaos. Now, our speakers are from Pathfinder Labs. They've flown from afar. I mean, the business is in New Zealand, but they have just arrived last night from a work trip to Pakistan. So please make sure that you loudly clap so that their jet lag is no longer an issue. Pathfinder empowers investigators in their mission to apprehend criminals and rescue victims. Their goal is to develop innovative products, infrastructure, tools, and services that convert data to actionable decisions for law enforcement professionals, just so that everyone is aware, because they work in the cyber criminal space. There might be sensitive topics that get discussed today. Just a disclaimer at the start. So, without further ado, please welcome to the stage Bree Atkinson, the CEO of Pathfinder Labs, oh my God, and Peter Pilley, the DevOps architect. Please give him a warm welcome.
Thank you so much. All right. G'day, how's everyone doing? There's a couple of people in the audience, this is great. I must admit, the lights are low, I'm a bit jet lagged, so if I do fall asleep, just throw something at me.
Can we do the I just flew in from Pakistan and boy, my arms are tired? Jeff?
Yeah, exactly. Yeah, well, you just
skip
did.
over that. Yeah.
So, well done.
Yeah.
Awesome. So I'll let Bree introduce herself, and because she speaks a lot better than I do.
So we are from Pathfinder Labs. We are from New Zealand. We're a tech company based there, made up of quite a collective of different skills and experiences. We have police investigators, we have judicial roles, prosecutors, ex-military, intel analysts, a whole wide range of experiences that are used within the workflow of a crime happening that is online facilitated and the prosecution of that offender, and then as well as that, victim services are provided after that. And we do that on purpose because the tools we're making, as the tagline says, is by investigators for investigators. What we don't want to be doing is producing software that we think is useful and then force it into a workflow. It comes from an informed place. So that's us in a nutshell, I guess.
Yeah, so one of the key parts when we're building any kit is everyone who works within like the development team or within the custom success teams have actually worked on the job within law enforcement or have worked on the job with the non-governmental organizations. So when we're building to fill those gaps are the ones that we identified when we were actually part of that job. So it's really critical for us to understand not only what the customers need, but also to really understand what those pain points are.
Who's got the button?
So we're going to do a little dance now as we.
Yeah.
It's voice activated. Next slide. Awesome. Oh.
Thank you. You going to be a charger button?
There is a lot of buttons here. The green button. Thank you so much. There was like a self-destruct button on this.
Ooh.
Awesome.
So, Bree Atkinson, I'm the CEO of Pathfinder, and that means my responsibility is to drive our team to innovate at all times. It has to be new, it has to be useful. And so we have sort of my customer's customer concept on who we are serving. The user in this case are investigators, but the beneficiary of the software really is the public at large and then victims at the end. So my job is to make sure everybody keeps that in mind and keeps innovating so that we're not making a tool that solves one problem and one problem only. It has to be constantly evolving and constantly relevant. And we do that using AI and automation and all those great things, which Peter has demonstrated by making himself recognizable within his profile with the very latest AI, which you can't even tell.
It's seamless.
Yeah.
It's amazing, actually.
Yeah.
So yeah, the only picture that we had was the stock one where I was pre-beard, and that's just not going to fly. And so using the latest in kind of large language models and generative AI, we're able to generate this masterpiece here. So, and also thank you very much to Canva, if there's anyone from Canva in the crew, for giving us the ability to do that very quickly. So my name is Peter Pilley. I'm part of the development team within Pathfinder Labs. I'm ex-law enforcement. I spent 14 years hunting pedophiles online and working in the other crime types as well, counterterrorism, money laundering, any of the areas within law enforcement that I was asked to do jobs on. My goal now is to lead the development team to build some of the cool tech that we get to do, engage with customers and work with other support teams on how to take a lot of their data, unlock it, and start identifying kind of key insights that are going to drive either public opinion, public policy, or even how to produce their services a lot more efficiently or effectively. Let's try the green button. And it works.
Yay. So a part of our role is connecting law enforcement and identifying what their problems are, where the pain points are, where the capability gaps are. And so we start that process by sitting down and talking with them. And we gather what issues they have and then confer them with the team that we have back home. And these are some of the commonalities that we have in the program, at least, that we're going to talk to about today. Do you want to launch into the communication part?
Yeah, so law enforcement traditionally are bad communicators, and we're bad at sharing information, largely because of what we're doing is generally kept as in a classified sense. There are a number of issues that surround that. That means information shared between law enforcement to NGOs or to other law enforcement can either take a significant period of time to get there, leading to cases not being solved effectively, or even people not being removed from harm. That data that is not being shared means that there is a ton of data sets that aren't being analyzed. What we've tried to do with the tools that we're going to be talking to you about today, called Paradigm, is how we've managed to leverage data sharing into the tool itself, but also the communication side to it now. We're able to move law enforcement to start communicating in the same way that developers do. Collaborative communication that kind of fosters that idea of, I have data, you have data, let's discuss what we have and find a better outcome very, very quickly. We've already seen significant successes in this, where one investigation team has enabled 40 investigation teams to be able to do their job. And those sorts of things, which our American counterparts call force multipliers, is something that's key to what we're trying to achieve.
So the questions come about is, how can I share the data? How can I share it securely? And then once I've got it, how do I process it? And how do I process it quickly, being the most important part of that process?
Absolutely. And then the last part there being removing barriers to entry. Barrier to entry for an investigator is largely going to be budget-based, but it's also going to be around knowledge, capabilities, qualifications, certifications. Removing a lot of those barriers means that data opens up, means that communications can open up, and cases can be solved a lot more quickly.
Mm. So our talk, Taming Chaos, is the chaos pertains to the data itself rather than the problem. And this is one source of that chaos. In the US, there's an organization called NCMEC, the National Center for Missing and Exploited Children. And their role is to collect and collate complaints of behaviors, activities, or individuals that are acting against the US law on social media platforms or anywhere on the internet. So they collect these complaints and then they send them out to law enforcement investigation teams or national state capitals and say, this is happening. Last year, they sent out 36.2 million of those referrals. Now, if we just looked at one referral, that could hold up to 15,000 pages, and often they're distributed in PDF, which is not overly accessible. So when you consider that it arrives on your desk and you now have the responsibility of reading 15,000 pages to find something of relevance, potentially a child that is at risk right now, that's a lot of pressure and a lot of processing to do manually. So that is just not doable, and that's part of the process, part of the chaos that we're acknowledging. So those are referrals. And on top of that, what we have here are two other sections, two other types of data that are coming in. The orange or amber is amber alerts. These are abducted children So they have quite urgently or recently been abducted and are now, Amber Alerts go out via text message, email. If you're in the US, they go on billboards on the motorways. It's very urgent, it's very now. But as you can see, there's quite a few of them active. Also in yellow are missing children, so that's on top of the NCMEC referrals that have already gone out. And you can see, certainly in Washington at least, there's 1.2 thousand within that one yellow dot there. So held within potentially that dot and all the other yellow dots are children that are missing right now, children that might have been gone missing for years, and everything in between. And so the challenge becomes, where is the relevant information? What can I use right now? How do I connect the data or the information from one case to another and back to the case that's on my desk today?
Exactly. And it's all about how do we connect law enforcement to this data. We talked about the cyber tips before, and they relate to people committing those offences on those popular platforms. It doesn't matter what platform it is. If it's based within the US, it will be reported through. But this represents the children that have gone missing within the United States, or the ones that have been abducted today, which is the red dots. And this is a snapshot in time, which is why there's only 4. But there are a significant amount of children who are abducted within the United States every year. And this is a really great point of time to kind of draw your attention to the red number that's up in the corner there, because by the time we've got to this part in our talk, there's 350 more referrals that have just been sent through to NCMEC that now need to be processed by law enforcement. We're going to be talking to you about 1 today. So as we're talking, these numbers are just increasing and increasing, and the amount of data that needs to be processed is just going up and up and up.
So that demonstrates the scale of the problem, and the step after that is the pressure felt by not only the agency that's receiving these complaints, but also the individual investigator. He can sit down and he can work on this, but as Pete said, at the time we're talking, he's now got 419 other cases he needs to get to as well. And thereby is where scalability and automation needs to come in.
Absolutely. So what do we want to do with Paradigm? So Paradigm is our primary tool that we build for Pathfinder Labs. We build other tools as well, but this one is really, really important to us. And so we want to take all those kind of project goals we presented to you at the start and turn them into kind of actionable items without the corporate lingo attached to it. So how do we simplify the data and evidence gathering side to it, but also the analysis side to it? Turn it into something that not only the investigator understands, but courts, judges, lawyers, the jury. How do we actually explain it when it comes crunch time to actually help us get that prosecution? How do we integrate data from other vendors? We shouldn't have to build everything for everyone. If there are other great vendors out there who have already built some awesome tools, let's integrate, let's collaborate, let's get that integrated in so other people get access to it. How do we future-proof those? So how do we take this technique or this capability or even just this inner kind of gut essence that a lot of investigators have, but make it transferable to other investigators? And then also the last part to there, which is really important to me, how do we minimize the overall costs?
These are agencies that have a budget. They don't have a budget allocated to just child abuse or missing children. And so you're fighting for priority within buying tools and spending time on these things. So what we want to make sure is that we're not developing a fabulous system that nobody can afford to use. That needs to be absolutely priority number 1.
So this is where MongoDB Atlas comes in. And I'm proud to say that I've been a Mongo user for many, many, many years. I'm a very recent MongoDB Atlas user, and I've been loving it since day 1. There are kind of so many things that we can talk about, and you're going to hear it from everyone else during the talks today about how they're using it, and I'm loving hearing how other people are kind of telling their story. But these are the kind of 3 main use cases that we're using MongoDB Atlas for at the moment. So one of the big parts for us is geospatial queries. What elements in my data are near my data, or where is my data in terms of the geolocation side to it, so the latitude, longitude information to it. The Atlas search, so how do I find a piece within my data? So this is the needle in the haystack, except we have multiple haystacks. And then the last part here, the Atlas vector search, which I was super excited when it came out. I think I posted like 16 or 17 times on social media about this, how amazing this is. The fact that I can now have this as part of my standard workflow without having to deploy other kit all the time to support our vector search has been an absolute game changer for what we're doing. And how we use it in our tool is this media that I'm looking at, so this piece of evidence that I'm looking at, is there anything else inside my data sets or anyone else's data set connected to Paradigm that is similar to what I'm looking at. And that's a really, really critical thing that we'll go into in the future. And then the last part is this chat thread that I'm looking at or my investigators are reviewing, is this known? Or is there anything else that kind of leads off this chat thread that would give us a different perspective of what's actually going on in this chat?
So some of those things that we're trying to identify are commonalities among location, the offender, the victim, platform, but also the sentiment. I'm constantly amazed. I'm not a technologist, but I'm in charge of running the team that uses these things, and constantly amazed at how accurate sentiment analysis is getting. And so what we have here is a statistic on online enticement, and that is children who are on a platform, and even some adults to be fair, and they are interacting with another individual who is encouraging them to behave in a way that they wouldn't normally do so. And sometimes that's incentivized with stickers or likes or payment of money or an exchange of views, etc. And what we've seen here is a 300% increase. Now, there's two reasons for that. One is that it is absolutely happening more. It is a crime type that's growing hugely, but also how it's being identified. So crawlers and analytic capability has increased so much that we can identify it in clarity, not just an indication of something, but we can alert an investigator to saying, this person is enticing this child to commit this act right now.
Exactly. And because we're getting better at detecting it, it means we need to make sure that the investigators are able to have that flagged immediately and have that rise up to the top to identify that this person could be grooming children or that they are showing indications that they are potential groomers. So here's an example of this. This is actually inside the Paradigm Investigation Toolkit, where investigators are able to see messages as they pop up through the case, as they're being ingested in, and they're being flagged by Paradigm and by the back-end services that support Paradigm. But at any stage, an investigator can say, actually, this chat should be classified as in this certain way, which immediately helps every other investigator. And this is part of our AI kind of workflow or our AI journey that's plugged into Paradigm itself, where we're constantly retraining our models to get kind of the best performance out of them, but also make sure that they're relevant and they're producing insights that are relevant and have a higher confidence or a higher prediction value so that our clients or our investigators know that when it flags it, it's going to have relevance to their particular case. This one's really cool. This is actually a real case here. Obviously, we've blurred out certain names so that you can't see who did it. But this was a real case of a missing female within the United States. She's been found. She was found within Texas. But at the time, there was kind of a lack of understanding of where she was or how all the information that surrounded her case was featuring back into this. And in this particular one, this took 3 investigators 12 months to perform. We ran the same case through Paradigm. We were able to come to the same conclusions, but actually with additional information within 45 minutes. And we only did that because of the fact that we could focus on the cool parts in terms of the software development, and MongoDB Atlas supported everything else, allowing us to make quick decisions and have that information presented to our investigators in the most efficient way.
And I think one of the cool parts of that is not only does it point out what is relevant and within there, but also what's missing. What information do you not have? And in that case in particular, what wasn't found by the manual investigations were 2 devices and I think up to 3 platforms that the victim was using. And so it's not only what you can see, it's what's not in the picture, and how important is that to you?
So how do we do this? So we use BERT as our model there. There are other ones out there, but this is the one that we've gone with because it's quite popular within law enforcement and within the developer communities that we're part of. If you don't know BERT, it's a great way of doing sentiment analysis. I've kind of stolen this from this person down here because I really like it. We call our BERT classifier grooming BERT because that's what he's designed to do. But the essential part to it when you're doing this sort of analysis of text, and we use the movie review side to it, was it a positive or a negative review? We're doing the same thing, but we're saying that this text here is showing a propensity for someone enticing or using threats or pressure against someone. That can be an adult or even a child. They're showing indications of what we call moving of platforms, trying to get someone onto an area where they have a bit more control in. And having that ability and using this, so we use the ones from Hugging Face to enable us to deliver those models and that experience to our investigators means that they get just quality information popping up straight away that, hey, there is some chat within these 15,000, 20,000 lines of chat that you have to analyze that are showing these indications. This person is approaching people in such a way, they are blackmailing, they are doing all these activities and have that bubble up straight to the top. I actually really love this one, but I feel really sorry that I have to say grooming Bert next to it. And so what does that actually look like on the other side? Now, this is the whole duck on a water analogy. The duck is all calm above the water, and below the water, the feet's going crazy. So we have all of our smarts that sit behind Paradigm, but for the users, what they're going to see is lovely little emojis or emoticons that pop up here. They're going to see just different ways that information is presented. So our persons of interest part is really key. I could have 60,000 potential persons of interest within a case. And that's just because of every sort of online interaction there is someone that could potentially be one of the targets there. And so with Paradigm, we're able to immediately bubble that up and show to the investigator, hey, this is someone that you maybe need to start focusing on right now. From all the chats themselves, we're able to label them. One of the ones that we're quite proud of is the ability to label toxicity. So to show someone who's is shown an indication of blackmail, threats, sextortion or extortion is really key. That plays a big part in online bullying investigation. So like the Amanda Todd side to it, or any other cases out there where someone has been bullied by other members of the public so much that they've ended up taking their own life. And that was something that we're really proud that we added in because it shows that we're able to immediately identify those. I don't know if you know, but sextortion, even within Australia, is a rising issue. There are a lot of young kids who have been coerced into taking pictures of themselves when they shouldn't be by people internationally and then being further blackmailed to produce more and more and more. And that's leading to, unfortunately, an increase in suicides, an increase in problematic behavior, and everything that goes along with it.
And in the case of financial sextortion, you've then got another added layer of data. You've got a money trail to track, you've got banks and identities, contact. So every time you investigate any of these crimes, the layers of complexity and added data just increase exponentially.
And then from all of that, we need to start identifying, if we have information there, where is this person located within the world? So we call this the where in the world problem. And so we use a lot of geospatial queries with this if we're able to obtain latitude, longitude information or IP data. But there's also one of our models in there which does geoestimation. So we're able to take an image there and based on a prediction, say where this is likely to be within the world. And this is one of the key parts for us from a victim identification perspective. We may or an investigator may only be given one image and then saying, we need you to find this person. And so we need to have cool tech that can support those sorts of initiatives. From the geoestimation side to it, we get a result. The result is going to be latitude, longitude data or long lat data, but we also have the original image information itself. And this is how we use that at the end of the day. Once we have that result coming from our model, we throw the image back through vector search to see, hey, is there anything else in this investigator's data set or any other data set that's connected to Paradigm that has a relationship to that image? And the latitude, longitude, or the long lats data that's coming in, is there anything that is near this location that an investigator currently has? And that could be drawn out of an image, so EXIF data that's inside an image. That could also be drawn out of chat information. If I'm saying, hey, I'm currently presenting at MongoDB Local today, it's in Sydney, why don't you come and join us? We're down in Darling Harbour. I've given away in my chat a lot of information about where I am. And using natural language processing, I can convert that into latitude, longitude information. And now I have the ability to match an image to text. So here's an example of it. This is one from a public data set that we ran through as for this particular presentation. This one's not from a case. So we have this image here, which is a nice image. We have Sanders Beach Rural Fire Brigade presenting behind it. And we threw this through our geoestimation model, and it gave us a nice little map at the end of it saying where likely this was taken. So it believes it was taken in Elliott. The actual one was taken from Sanders Beach Rural Fire Brigade just up the top there. So it's not, in this instance, it wasn't 100% accurate of where it was, but it gave us a general location of where to start finding things. Awesome. We don't need 100%. We just need something to give us an additional kind of leg up when we're doing our investigation. This took roughly a second to produce this sort of information for the investigator and give them that additional lead. There's a lot of other information that we can take from this. We could start Googling around it from an open source intelligence perspective to it. We could look behind the image and start drawing out EXIF or metadata that could be stored inside the image. There's so much more that we can be doing there, but we're talking about 36.2 million cyber tips. You can't do that on every single case. And again, there's over 1,000 referrals that have now been received by NCMEC by this point of my case. We need to be able to automate this. Oh, green button's not working. There we go. So we get some information out of our geoestimation models that give us a potential location there, chuck it into our geospatial query, find out do we know anything else about that, throw that through our vector search, is there any images that are close to this, and we get this bad boy presented straight away. Now what's very cool about this, oh, can I go backwards? There's a red button. Does the red button make everything explode? No, cool. So we have this image here, and we have the previous one. Well, there's some obvious differences here. The obvious one is there's not two people standing in front of it anymore. But the next one is this is blue. So now we've got an additional piece of information that we didn't previously know. At some point, they changed the color of it. We've now got a timeline that we can hit on. If we can find out what time or when they painted that, that's going to tell us when this image was taken. Now that we know when that image is taken, that's going to give us another avenue that we can start the investigation on. And this is all done within seconds. And if we had to do this in the old ways, this would have taken us weeks, if not months. And this is why I really love technology. I really love talking about what we're doing, because it's these sorts of connections that enable cases to be opened wide. So from the data analysis side to it, which is obviously the key to what we're doing, we're taking very, very large data sets that are just getting compoundingly large every single time a case is opened. And we need to be able to have that information presented to the investigator to show, hey, inside your data, inside your case, these things are really critical. These things match to other people's cases, enabling you to do your job faster. We've had it in other cases within Paradigm where the case has almost been solved at the point of opening it up, because it's been able to link it to other cases, other offenders, other victims that are in there. The highlighting persons of interest is really key, because now we start seeing proclivity of offending. And then this last part that Bree went through before, identify what data is missing, has actually turned out to be an amazing thing. And it was, to be honest, it was discovered accidentally. Because we were looking for gaps, we didn't really know how to program for them, but it just kind of happened naturally. And that led us to having whole systems now that can point out this person's referring to this, but they are showing other evidence in other areas. And that last part there also helps us inform public opinion. It helps us advise people on how to do or develop better victim support services, better offender management, better legislation. And then this part is one of my favorite areas. I call this the Philip Waffler approach. If I'm ever doing anything in terms of MongoDB Atlas, I really love the fact that I get a little email saying you're doing it wrong, and you can do it better.
And that's just not from me.
No, exactly. This is something that actually blew my mind. Outside the vector search side to it, the performance advisor and the schema anti-patterns is just the quiet way of something whispering in your ear, no. And then you get to adapt from it. That performance advisor alone has solved so many problems that we created within our own schemas. I love data structures, I love designing schemas, but sometimes you forget the end result is how do you get that information to the users, and how do you do that efficiently? The amount of times we've kind of patted ourselves on the back saying, look what we did, but we've been able to make it faster just by doing one change that the performance advisor has done. Now we've got 10 seconds to go, but I think we're actually pretty good. And everyone says they've built Kit, and it sounds like they've done it on their own. We did it with all of this, and there's actually more here. I can't fit them all on the slides. So I can't thank everyone enough, but we got there with everyone else's help. It wasn't just us who did this. Yes. And that's us.